I'm honored to be speaking for the second time in less than a month, and to be given this opportunity by DYPCOE College. I thank you to Principal Sir, Vice Principal Ma'am, and all the staff to give me this opportunity again to speak to you. Today, I'll be speaking on data science while the staff to give me this opportunity again to speak to you. Today, I'll be speaking on data science one. So we have a few commonalities over there. Okay, so going ahead, I started my career at Mu Sigma and I worked there for about 2 years, 2.5 years, before I took the leap and moved to Singapore to do a master's.
His sound bent.
Hello. Yes, sir. Akshay sir. Hello, Akshay sir.
Yeah.
Sir, I think you have muted your audio. We could not hear you for last 2 minutes.
Oh, okay.
Now it is audible, sir. But
all right. Yep.
okay.
So I was just saying that. Sorry. Okay, let me just start over. So I was just saying, as Kulkarni sir mentioned, that Mu Sigma actually comes to DY Patil College of Engineering. Coincidentally, I was also placed at DY Patil because Mu Sigma only came to DY Patil at that point in time. So that is one commonality I have with DY Patil. And I started my career at Mu Sigma, worked there for about 2.5 years before moving to Singapore, where I did a master's course at NUS, National University of Singapore, and the course was in business analytics, post which I started working with Unilever, wherein I was helping the sales and marketing teams try to increase sales and reduce cost. This was all using data science. I was part of the global data science team there as well. After working for Unilever, I joined Lazada, which, like I said earlier, is the largest e-commerce company in Southeast Asia. I was working in the recommendation team essentially. So we were trying to recommend products and products to people and trying to personalize stuff for them on the app. Now I have taken the leap of faith to come into the travel industry, and I've joined a travel tech company called Pelago, which is part of Singapore Airlines. And I'll probably I'm essentially laying the foundation to do recommendation and personalization within Pelago. So next time, if you come to Singapore, you can probably use Pelago, which will come out later this year, and you can find some travel experiences within Singapore to enjoy. Cool. So moving on, I wanted to cover what is data science in this webinar. Then why do we need data science? Then I'll take you all through a data science project lifecycle. And lastly, what you can do as a student to start your data science career. So that's going to be the agenda for this meeting. So talking about what is data science. So before you try to understand data science, you already would have heard a lot of terms and terminologies around data science. The most commonly used terminology is artificial intelligence. So think of artificial intelligence as nothing but a technology that enables machines to think like humans, right? And what makes us human is the ability to learn from experience. In this case, machines use data to learn from experience. For them, experience is equal to data, right? Whatever has happened in the past, they can learn from that. So a subfield within artificial intelligence is machine learning. So machine learning is nothing but a technology or a set of algorithms that try and improve their predictions automatically through this experience. And by experience, again, it means through looking at historical data. Now, a very specialized field under machine learning is called deep learning. Deep learning at this point in time, you should think about it as just machine learning with tons of data. So if machine learning, you're using, let's say 100 rows of data, deep learning is using millions and millions of rows of data. So what is data science? Data science includes all of the above and probably more than that. So a data scientist is involved in every aspect of a problem solving, right? From where a business comes to you and gives you a problem saying, this is the business problem. So a data scientist needs to understand that problem. Then he needs to go and figure out or explore the data that has been provided or the data that is relevant for this for the solving of this problem. And then he will go on and try and use one or more algorithms to come up with a prediction to say, okay, let's say my sales have decreased. So I need to find out the root cause of why my sales are decreasing in a particular industry. So he'll go and find out the relevant data, and then he will go and present the insights to the business person back. So an end-to-end process from understanding the problem to finally giving a solution back to the business person and making him understand through data is the role of a data scientist. So let's talk about this more, right? What exactly does a data scientist need to do, or what exactly is data science? So data science is a combination of mathematics and statistics, domain knowledge, and software engineering. And so data science is essentially in the center of all of these. You cannot do data science by just having an understanding of math and statistics. You cannot just do data science just by knowing software engineering or just having domain knowledge. You need a combination of all the three, right? So in data science, you require an understanding of concepts like probability theory, regressions, machine learning for mathematics. You require knowledge of the particular domain. For example, if you are in the supply chain industry, the way you would solve a problem in the supply chain industry and trying to optimize the supply chain there is going to be very different from how you would solve a problem in the e-commerce industry. So having a sense of that is what differentiates data scientists from other people. And lastly, data scientists today are also required to understand and be able to code well. And after coding well, they also need to deploy their products and solutions online. So it is automated and it works on and on for the company or the industry that they're working in. So now you might be wondering, why do we need data science, right? The world was working perfectly well. So why did data science come about, and what really happened, right? What really changed? So traditionally, people believed in individual experience and people believed in intuition. So let's say there was a business person who had 10 years of experience, right? He would generally be at the top of an organization taking crucial decisions. Now, earlier it was feasible to use industry experience as a way of saying that the decisions taken by experienced people are generally better and their intuition works better in the long run and they are more likely to succeed than someone who is with 2 or 3 years of experience, right? But like I spoke about in my previous talk about a VUCA world, this world has changed, right? Our world is far more complex and ambiguous to be able to take decisions just using intuition and experience. And individual experience can be biased, and therefore we need to rely on data. Data is the truth. Data is facts. Whatever you do with data is going to be far more likely to succeed than using individual experiences. For example, if you have 5 people in your company with 10 years of experience, all 5 of them may not come to the same decision. But if you have 5 sets of data, all of them will likely come to the same decision point, right? And that is why organizations and people around the world have started trusting data far more than individual experiences. So essentially, data science is the art of generating value from data, right? So let's say you have some data. What can you do with it? You can try and increase sales with data. For example, you own a shop, right? You own a candy shop. You know that looking at historical data for the last 5 months that you've been running it, you've realized that Cadbury chocolates sell more than Nestle chocolates. So what do? Looking at this historical data, you know there is a higher demand for Cadbury chocolates. So you will go and tell your distributor to send you more Cadbury chocolates and prioritize Cadbury over Nestle, which will in turn increase your sales. Next time the customer comes in, he will never find that your stock for Cadbury is out, your shop is out of stock for Cadbury. That is the simplest use of data. You can reduce cost. Organizations and businesses around the world are trying to become profitable. Today, data science enables us to automate certain tasks that could be done by humans. If I write a piece of code, let's say it's about 100-line piece of code, and it can automate the job that 10 people do in a day, I would take this solution and try and automate their job and try and reduce my cost, right? Probably those 10 people will be required to do far more intelligent tasks, right? I can use their resources much better. Or probably I don't need 10 of them, I need only 5 of them. You can identify new opportunities with data. So let's say you're trying to open a new shop, right? If you're trying to open a new shop, you'd probably go and do a survey around your locality, trying to identify which is the best spot for your shop. So you try and collect some data around what are the sales in various shops around. If there is a college nearby, probably the sales of shops around it, stationary shops around it, is high, versus if there is a hospital around it, a medical shop sales are high. So collating all of this data, you would realize that depending on the type of shop you want to open, you would open a shop near a school or a hospital. Again, this is using data. Lastly, you can optimize supply chains. So a product, so think about raw material, right? Raw material from its source, let's say paper. When paper is produced, the first thing that you need to do is cut a tree. Right from cutting a tree to making a book out of it and reaching a student in class, there is a complete supply chain within that. Data science allows us and enables us to optimize this supply chain. There are various steps involved in this, and trying to understand inefficiencies within your system, you can do that with the help of data and data science. Cool. So let's talk about some of the applications of data science. Okay. So you might be visiting Google very often, and you might be typing in, or you might be trying to search something on Google. And very often you see there are ads popping up in the first 3 or 4 searches. So what are these ads, right? These ads are trying to predict what you're most likely to click on. Obviously, these ads are sponsored by companies, but essentially there is a data science algorithm behind it to say that you are most likely, when you search for online learning, you are most likely to search for Udemy over Harvard Business School, right? So the ranking of these links that you are given out is done using data science algorithms. Facebook again uses data science extensively. Whenever you log on to Facebook, somehow it finds a way to recommend you people that you've not added on Facebook, but you know. How does Facebook know that? There are sophisticated algorithms through which Facebook is actually mining your data to identify all the people you're connected with and then creating those relationships in the background and then finding a person that you've not befriended, but your friend has befriended. So these sophisticated algorithms are running in the background to provide you more ways to engage on Facebook. When you're ordering a cab, on Ola or Uber, there might be about 10 drivers around your place, but the algorithm is smart enough to allocate the ride to the specific driver based on the driver rating, the customer rating, which let's say you are ordering the cab. So it matches your rating with the driver's rating. It looks at where your source is and where the destination is. For example, a driver a driver does not want to go to Lohegaon ever, right? So every time he gets a ride to Lohegaon, he always cancels it. So Ola or Uber might be recording this data, and they are recording this data to say, this guy does not like to go to Lohegaon, so I'll never give him a ride that is going to Lohegaon. But he loves going to Kothurud because probably it's close to his home. So every time the ride comes in, he is more likely to get a ride to Kothurud than to Lohegaon. This is an interesting one. Elections around the world are using data analytics and data science today. So even in India, and probably in no more in 2019 than ever before, data science was used extensively. And probably all the WhatsApp messages that you receive on your phone are in a way influencing the decisions you make, and probably are influenced by what you like and which party you like or you support versus other parties. So all of this data is being captured by various organizations around the world to provide you with information or even influential material to sway elections one way or the other. In the manufacturing industry, we've gone ahead and started using Internet of Things. Internet of Things is essentially all devices connected to a single source system and continuously sending in data around the machines. So if a machine is about to fail, today computers can actually predict whether it is sustainable to run it with the inefficiency, or it is also able to predict at what time a machine is likely to fail. All of this data is being captured now, and there are sophisticated algorithms or data science algorithms to predict when a machine can fail. Lastly, your phones are now empowered with data science algorithms. Whether you know it or not, there are tons of algorithms written inside your phone, and they run every time you use one or more apps. For example, sometimes you try to unlock your phone with your face, a facial recognition algorithm is running in the background. So coming to a data science lifecycle. So how do you go about solving a data science project, right? The first thing is try to understand the business problem. What is the business problem? I've taken this example before. Let's say you're trying to open a shop, right? So what are you going to do? Are you going to just say, okay, I think my shop, let's say I'm going to open a candy shop or a stationery shop. Okay. Cool. So let's say you're trying to open a stationery shop. Are you going to just say, I'm going to open it in locality X versus locality Y, just because you think and you've spoken to a couple of people saying that, okay, stationery shops run well in this region. It might work, it may not work, but to be certain that it's going to work, what you can do is you can do a bit of data exploration, right? You can go and survey all the shops in all the localities that you're thinking of, and you can go and do a survey around shops, right? So what is the data you're going to collect? You're going to collect data around how far is that shop from the nearest college or school. You're going to collect how much sales he makes in a day, what is the rent that he has to pay, and you're going to collect this information from various shops, right? Now, using this data, you're going to come up with certain insights. You're going to be able to come up with certain factors saying that, okay, if my shop is 1 kilometer away from a college or a school, it works well. But if it is more than 2 or 3 kilometers away, it doesn't work well. So these are some insights, and these are some insights that you can come about from data, right? And then you can build sophisticated algorithms using some statistical concepts to say that, okay, distance is 100% directly or indirectly proportional to sales. Then you can also say that the rent of a shop is probably directly proportional to the sales of the shop as well, right? So these are the insights that you can draw. Then based on these insights, you are going to, in this case, let's say you have to open a shop and you have to do a survey for your dad. So you need to collate all of this information and the insights and to communicate it to your dad, who is going to put in the money for this shop. So to be able to explain whatever you've done with your data in a way that he understands is visualization, validation, and communication, right? So you cannot tell him that I found out from data that so and so variable is highly correlated with this. Probably he may or may not understand, but if you can explain to him in simple English, he is going to understand and probably give you the money to open that shop, right? Finally, if he's convinced with your business idea and your research, he's going to take a decision and probably give you that money. So a data science project in a business world also works in a similar way. A business person comes to you, let's say the chief marketing manager comes to you and he gives you a business problem saying that, okay, find out how you're going to increase sales for product X and product Y. So you got to go and collect data, generate insights, go back and communicate whatever you've done through your data and findings, communicate that information in simple English for him to go and take a decision again, right? And in a tech world, that decision is essentially whether your code gets deployed or not, right? So now that we've understood how a data science project works, what data science is, and what are the applications of data science, you guys might be wondering how you can start your data science career, right? Because there is essentially very little formal knowledge that we're getting in our universities at this moment. And my dad was telling me this morning that there is a course about to start on AI, right, in the next session. So at this stage, probably we don't have any courses. So how and where do you start? So we've seen this diagram before, wherein I said or I explained that data science is a combination of math, statistics, domain knowledge, and software engineering. And that is what makes a data scientist. But really, can you can you learn and can you get enough in-depth knowledge about all of these three aspects to eventually become a data scientist? Yes, but you don't really start on day one over there, right? Probably you've gone through a course of math and statistics in your undergrad, or you are a software engineer today and you want to become a data scientist. So is there a bridge between that? And yes, there is, right? Okay. So there are different data science roles. Not everyone is a data scientist, and not everyone requires 100% knowledge or 100% understanding of all three aspects. So I started off as an analyst as well. And the role of a data analyst is to help generate business insights for businesses to take actions. So they are well versed with domain knowledge and math and statistics, but they don't have as much understanding of software engineering. So that is probably a starting point. Or if you're good with math and you're good with your software engineering, you can become a data engineer. So data engineers enable data scientists with infrastructure to help them do data science. So there are these roles, and there are many more of these roles. There are roles like business analysts and other stuff. But to be able to enter and to be able to enter this field, you at least have to have information or knowledge about one or more fields, right? So there is a starting point, but eventually you need to find out your roadmap to becoming a data scientist, or you want to become specialized in analyst roles or engineering roles.
Hello.
Yeah.
Hello. Sorry, sir. Last 3 minutes. I just wanted to remind you. We have
Okay.
just last 3 minutes. Sir.
Okay.
Okay. Sir.
Okay. So how do you get into the data science industry? Again, I'm going to give you about 3 or 4 simple steps. First is do your research. Google, right? Everything that you want to know is available on Google. So do your research well. Again, you can go on online learning platforms to identify what are the best sources of knowledge. You can look up websites like Analytics Vidya. You can compete with other data scientists around the world on Kaggle. You can do some online learning on Coursera. There are many companies in India that are looking for freshers, fresh out of college, and getting them trained to do data science. Right? I was part of Mu Sigma. There are many other companies like Fractal, Tiger Analytics. Tiger Analytics is a company based out of Pune, and many more. Right? So the data science field is vast, and opportunities are endless. Lastly, like I said in the previous slide, you need to find your career path, whether you want to become an analyst, engineer, or a data scientist. After you've got a job in one of the companies or wherever you're looking at, you need to find your career path, right? And none of them is more or less than the other. Each one has a specialized field of its own. Okay, so this is a data science roadmap covering concepts, tools, and technologies that are required of a data scientist. I started off with this diagram very early in about 2015. I started with this, and it helped me a lot in my early days. You can look this diagram by Swami Chandrasekharan. It's a very good starting point for data scientists around the world, and sort of the mantra for data scientists. If you'd like, I can share it with you as well. And lastly, yeah, in God we trust, all others must bring data, at least in the data science industry. That's it from my side. We can take questions if you'd like.
Thank you so much. Thank you so much for sharing your expertise on this, sir. And thank you, Akshay, sir, for letting our students know the importance of data science. And thank you for sharing art of generating value from data to share their career. Thank you so much, sir.
Thank you, ma'am.
Yes. Over to you, Kulkarni, sir.
Thank you very much, madam. Thank you very much for the excellent session, sir. And before going further, I must say that there was an analogy in artificial intelligence domain that God is a data scientist. God created his artificial intelligence product called humans, and a great supply chain system developed by God is called as solar system, that is suns and planets. So thank you very much for this.
Yes, sir. Thank you, sir.
Thank you. Thanks a lot. Moving around to the next session today. The third
Kulkarni sir,
session.
excuse
Yes,
me.
madam. Yes, madam.
Sir, we have to make one important announcement.
Please,
For
please.
2 minutes,
please go
I'll
ahead.
make that announcement. Yes.
Please go ahead.
So, dear students, we are sharing one link of Drive on the in the chat window right now. You are supposed to download the document from this Drive link, which we have pasted in chat window. It is compulsorily required for the second session, which is a hands-on session. So you should be downloading this document before you are getting connected to second session. Varush sir will be pasting that in a chat window. All students are requested to download the documents from this Drive link, which we are sharing in chat window. It is required for second session's hands-on session. Thank you. Over to you, Kulkarni sir.
Thank you very much, Trupti madam. And before going further today, the third session, they remind me one incident in Board of Studies meeting of Academic Council in University of Pune when this AI and data science course was coined. That time everybody was asking the question, that is, what will be the subjects, what will be the scope, what will be the application areas, and which are the other interdisciplinary domains that will be coming out in artificial intelligence and data science. And to be very specific, Dr. Varsha Patil madam asked very specific question to mathematics BOS. That is, how many mathematics subjects you want to be in AI and data science, and what are the scope and relevance? I think that scope and relevance everybody must be analyzing now or imagining, and who